Somewhere in the sky right now, there's a patch of light so small that you could cover it completely with a single grain of sand held at the end of your outstretched arm. Inside that tiny patch sits a faint red smudge that should not exist. It looks like a mistake, a flaw in the camera, the kind of thing any astronomer would normally throw straight into the trash bin of bad data. Except it is not a mistake. It is real. It is confirmed. And it just forced scientists to admit that something about the early universe does not add up. Stick with me to the end of this video because by the time we are done, you're going to understand why one of the most respected astrophysics teams on the planet looked at this object and basically said, we do not fully understand what we are looking at. That faint red smudge has a name now. Scientists call it Mu-MZ-13, and the story of how it was found and what it might mean is one of the strangest things to come out of space science in years. Now let's start with the basics, because you need to understand just how old this light actually is. That tiny red smear left its home galaxy roughly 13.12 billion years ago. To put that in perspective, the universe itself is about 13.8 billion years old. This light has been traveling toward us for almost the entire history of everything that has ever existed. It crossed a universe that was constantly stretching and expanding underneath it the whole time, which is exactly why its color shifted so dramatically, sliding further and further toward the red and infrared end of the spectrum the longer it traveled. By the time it finally reached the giant gold-coated mirrors of the James Webb Space Telescope, it barely resembled visible light at all anymore. And when scientists finally managed to capture and measure that light properly, they ran into a serious problem. This galaxy is too bright, it is too small, and it is chemically too advanced. It looks like something that had already been operating for a very long time at a point in cosmic history when almost nothing was supposed to exist yet at all. To really understand why that is such a big deal, you first need to understand what the universe actually looked like before there was anything worth looking at. Light travels at roughly 300,000 kilometers every single second. That is simply the fastest anything in the universe can ever move. But space itself is so mind-bendingly enormous that even at that speed, a single particle of light can spend more time traveling through the universe than planet Earth has even existed. Our universe is about 13.8 billion years old. All right. But for its first few hundred million years, there was nothing to see at all. No galaxies, no stars, no planets, no chemistry. Just a thick, dim fog made almost entirely of hydrogen and helium gas, expanding outward into total darkness. Astronomers call that early stretch of time the cosmic dark ages, and the name is not just poetic. It is literally accurate. That primordial fog was so dense that light could not travel freely through it at all. Even if you had somehow been floating right in the middle of it with your eyes wide open, you would have seen absolutely nothing. Eventually, gravity did what gravity always does. The fog slowly began clumping together. Denser pockets of gas pulled in more material, collapsed further, heated up, and eventually ignited into the very first stars. And these were not gentle, well-behaved stars like our sun. They were enormous, violent, and extremely short-lived. Their intense ultraviolet radiation tore through the surrounding neutral hydrogen gas, stripping electrons away from it and burning clear, transparent bubbles into the thick cosmic fog. Those bubbles kept growing, kept merging with each other, and slowly the fog lifted entirely. Scientists call that transition ionization, and the moment it began is what we now refer to as the cosmic dawn. Every major telescope pointed toward the deep universe is, in one way or another, trying to catch a glimpse of that exact sunrise. And with every passing year, we managed to push our observations a little bit closer to that historic moment. Until fairly recently, the record for the most distant confirmed galaxy ever observed belonged to an object cataloged as JADES GS ZD14. Another discovery made using the James Webb Space Telescope. Its redshift was measured at 1418. Now, redshift is essentially a way of measuring how much the ongoing expansion of space has stretched a light wave during its journey toward us, and it functions almost like a built-in clock. Redshift that high told scientists the light they were looking at had departed its source when the universe was only about 290 million years old. That already sat right at the very edge of what anyone expected to find. Then, a research team working out of the Kavli Institute at MIT decided to go back through imaging data that Webb had already collected, specifically hunting for promising candidates that other researchers might have overlooked or passed by too quickly. And they found one. It was an object that showed up clearly at longer infrared wavelengths, but essentially vanished completely at shorter wavelengths. Exactly the kind of signature you would expect from light that has been so severely redshifted that its entire blue end has been erased. That pattern alone was suspicious enough to justify dedicating precious telescope time to it. In the spring of 2025, The team pointed Webb directly at the object and ran its light through an instrument called NIRSPEC, which splits an incoming beam of light into its individual wavelengths. Essentially, the same way a glass prism splits ordinary sunlight into a rainbow. That is genuinely how scientists stop guessing and start actually measuring something with real precision. When the spectrum came back, it confirmed a redshift of 1444. They named the object MOE-EMS 14, and with a single confirmed measurement, the previous distance record was broken. We are now looking at light that departed its galaxy roughly 280 million years after the Big Bang, at a point when the universe had only lived through about 2% of its entire existence so far. Let's try to actually picture what that means. Imagine compressing the entire history of the universe down into a single calendar year. The Big Bang happens in the very first instant of January the 1st. This galaxy is already shining brightly by around January the 7th. The dinosaurs do not even show up until the day after Christmas. Every single human being who has ever lived fits entirely within the last few minutes before midnight on New Year's Eve. And somehow, we built a machine, launched it roughly 1.5 million kilometers away from Earth, and managed to catch a single particle of light from the very first week of January. Here is exactly where the real trouble begins. MAMS I-14 is tiny. Its visible light spans something like 240 light years across. For comparison, our own Milky Way galaxy stretches roughly 100,000 light years from one edge to the other. We are talking about literally hundreds of times more compact than the galaxy we live inside of. Something closer in overall scale to a single dense star cluster than to what we would normally call a full galaxy at all. And despite being so small, it is absurdly bright. Pound for pound, this object is putting out far more light than anything that young and that compact has any business producing, according to our existing models. Standard formation models tell us that early galaxies at this stage of cosmic history should look dim, messy, and slow to fully come together. This one instead looks compact, mature, and intensely energetic, almost as if it skipped several stages of normal galactic development entirely. So, what exactly could be powering something like this? Scientists have proposed a few different possibilities, and each one comes with its own uncomfortable implications. One option is that star formation in the extremely early universe was far more efficient than anyone previously assumed, with gas collapsing into new stars unusually quickly, and with almost none of the typical inefficiency we see in galaxies today. Another possibility is that the very first generation of stars ever formed were so massive and so blisteringly hot that a relatively small number of them could genuinely outshine an entire fully formed modern galaxy all on their own. And a third possibility is that something else entirely is feeding at the very center of this object. Potentially an extremely early black hole actively pulling in surrounding material and radiating enormous amounts of energy as it does. Every single one of these explanations would require scientists to seriously revise something fundamental about how they currently believe the early universe actually worked. But surprisingly, the brightness itself is not even the strangest detail buried inside this discovery. When researchers examined the full spectrum of light coming from this galaxy in more detail, they found a very specific chemical signature inside the surrounding gas. A ratio between nitrogen and carbon that came back unusually, almost impossibly high. Here is why. The particular detail matters so much. Heavier chemical elements are never free. The universe was originally born containing almost nothing but hydrogen, helium, and a tiny trace amount of lithium. Every other element that exists, including the carbon inside every living cell, the nitrogen woven into every strand of DNA, even the oxygen you are breathing in. Right now, all of it had to be manufactured inside the cores of stars first, and then violently thrown back out into space whenever those stars eventually died. Building up a meaningfully enriched chemical environment inside any galaxy genuinely takes multiple full generations of stars, living, dying, and recycling their material back into their surroundings. At only 280 million years old, there should have barely been enough time for a single full generation of stars to complete that entire life cycle, let alone enough generations stacked on top of each other to explain the kind of chemical imbalance researchers actually detected here. And there is a second, equally strange layer buried inside this same finding. That exact nitrogen-rich chemical signature has also been observed somewhere else in our own cosmic neighborhood, inside something called globular clusters, extremely dense, ancient spherical collections containing hundreds of thousands of individual stars, typically found orbiting around the outer edges of galaxies, just like our own Milky Way. For a long time, these globular clusters have been treated as leftover relics from somewhere within the first few billion years of cosmic history. If MOAS-SO is already showing that exact same distinctive chemical fingerprint, It suggests that whatever process actually builds structures like globular clusters may have started kicking into gear almost the moment the early cosmic fog cleared away. Entirely. That does not simply nudge our existing timeline slightly earlier, it genuinely compresses it in a way that is difficult to fully explain. Now, at this point, you might reasonably think, fine, this is one strange, unusual object. And outlier discoveries like this happen sometimes in science. Except this is not just one weird, isolated case sitting off in a corner somewhere. Ever since the James Webb Space Telescope began fully operating back in 2022, it has been returning some version of this exact same surprising result over and over again. Galaxy after galaxy, spotted deep in the early universe, keeps turning out too luminous, too developed, too chemically enriched, and too structurally organized for the specific moment in cosmic history we are catching it in. What researchers originally expected to be a small handful of rare exceptions has quietly, steadily turned into something that increasingly looks like the standard result instead. This matters enormously because our current scientific framework for how large scale cosmic structure actually assembles over time was never something casually sketched out on the back of a napkin. It represents decades of careful observation, detailed simulation work, and repeated testing, and it has genuinely survived an enormous number of those tests successfully. That framework is not simply wrong. But it does keep getting surprised again and again in this exact same direction. And a scientific model that keeps getting surprised consistently in the same specific direction is a model that almost certainly has some kind of genuine gap hiding inside it somewhere. Maybe dark matter played a far more aggressive role in seeding the earliest cosmic structures than current models are properly accounted for. Maybe the underlying physics governing that very first generation of stars is meaningfully different from anything currently sitting in our existing scientific catalog. Maybe there is some entirely unknown mechanism actively operating during those first 100 million years of cosmic history that scientists simply have not fully imagined or identified yet. None of that represents science failing at its job. That is actually science doing precisely what it is supposed to do, running directly into a genuine wall of contradictory evidence and refusing to simply look away from it or pretend the problem is not really there. And it is extremely likely that this particular distance record will not stand for very long either. Researchers involved in this discovery have already stated publicly that Webb appears fully capable of pushing this cosmic frontier back even further, potentially reaching red shifts that were considered completely unimaginable only a few years ago, edging ever closer toward the era of the very first stars in the entire universe. There's also a completely separate, genuinely strange anomaly sitting inside Webb's broader deep field data, and researchers are still actively debating whether or not it might somehow be connected to everything we have just discussed. When a separate group of researchers went through Webb's deep field images and carefully sorted a large sample of spiral galaxies based purely on which direction their spiral arms happen to wind, essentially telling you which way each individual galaxy is spinning, the resulting count came back noticeably lopsided. A clear majority of these galaxies appeared to be rotating in the exact same direction as one another in a universe with no built-in preferred direction or orientation. That number should land somewhere close to an even 50-50 split, roughly half spinning one way and half spinning the other way. There's no obvious reason the wider cosmos should have some kind of built-in favorite rotational direction. The researchers behind that particular study raised a genuinely wild-sounding possibility to help explain it, one that honestly sounds like it belongs in a science fiction story rather than a peer-reviewed paper. What if that spinning imbalance is actually a kind of leftover residue from the specific conditions our own universe originally formed inside of? What if, in some very real physical sense, our entire observable universe is actually sitting inside something like a black hole? Stick with the logic here for a moment because it is genuinely more coherent as a scientific hypothesis than it might sound at first. When enough matter collapses together under its own gravity, it eventually forms what is known as an event horizon. Essentially, a boundary surface that not even light itself can ever climb back out from once it crosses over. Cross that boundary, and from the perspective of literally everyone standing outside of it, you are permanently gone. What actually happens beyond that boundary remains genuinely unknown territory scientifically. Our current mathematical simply hand us an undefined infinity and stop being useful at that exact point. A concept called black hole cosmology takes that specific gap in our understanding and offers one possible way of filling it in. What if the interior of a black hole is not actually some kind of dead end at all, but is instead a separate region of space that continues expanding on its own? What if everything we currently call our observable universe is simply what the interior of a black hole genuinely looks like from the inside? Now, connect that idea back to the very beginning of everything. Our standard scientific account already describes the universe as having started from something called a singularity, an infinitely dense single point, which happens to be the exact same term scientists use to describe the theoreticus, L center of any black hole. Under this particular interpretation, the Big Bang was not necessarily some kind of explosive eruption happening into completely empty surrounding space. It may instead represent the far side of a gravitational collapse that happened somewhere else entirely, inside some larger parent universe at a moment when a sufficient amount of matter fell together and sealed itself off behind its own event horizon. I want to be genuinely fair and balanced here because there is also a much simpler, more grounded explanation available, and intellectual honesty requires putting it clearly on the table as well. That spinning direction imbalance we mentioned could ultimately turn out to be nothing more than a measurement artifact. Our own Milky Way galaxy is itself constantly moving through space, and that motion can subtly brighten certain objects that happen to be rotating against our direction of travel, while slightly dimming objects rotating along with it instead. If our current estimate of the Milky Way's own rotational motion turns out to be even modestly inaccurate, that alone could introduce a real statistical bias into this kind of data without requiring any deep cosmic mystery to explain it at all. That same healthy scientific caution applies just as strongly to M100Z14 itself. Small sample sizes can genuinely mislead researchers. Early measurements sometimes get meaningfully revised once additional data comes in. Some of what looks completely impossible today may end up looking fairly unremarkable within just a decade or two, once our instruments and our underlying models both continue to improve. But here is the honest, balanced position to actually take away from all of this. Not that the idea of our universe existing inside a black hole has somehow been definitively proven. And also, not that the entire concept is simply nonsense to be dismissed outright. The honest position is that we are currently standing in front of several separate, seemingly unrelated pieces of evidence, all quietly pointing in the same uncomfortable general direction at the exact same time. A galaxy that appears to have formed far too quickly, chemical enrichment that arrived far too early, and a section of sky that seems to display a strangely preferred spinning direction. Roughly 13.5 billion years ago, the faint red smear of light left its home galaxy carrying a genuine scientific question we still cannot fully answer today. It has been quietly traveling through the expanding universe ever since, patiently waiting for someone, somewhere, to eventually build a mirror large enough and sensitive enough to finally catch it. We finally did exactly that. And the very first thing this discovery told us is that we currently understand considerably less about the early universe than most scientists confidently assumed just a few short years ago. So, what do you personally think is really going on out there? Drop your honest thoughts down in the comments below, and if this kind of deep space mystery genuinely fascinates you, make sure you are subscribed to this channel because we cover discoveries exactly like this one on a regular basis. Real findings, straight from real published research, explained clearly without unnecessary exaggeration, because today, once again, the world of space science just got a whole lot stranger.